All right, so we're recording at this moment. So kinematics. Kinematics basically is the study of displacement, velocity, and acceleration, or position also. All right, so we're gonna talk about this problem. I'm gonna let you guys do this problem basically as homework, okay? But we're gonna talk about it so you have idea what they're talking about. All right, so it says that Michael rides up a hill and down the other side to his friend's house. The dots on the graph show, let me see, somebody's here. All right. The dots on the graph show Michael's position at various times, right? And then it says that the distance Michael has traveled at various times is given by that function S of t, 1.2 t cubed minus 30t squared plus 285t. And the time is measured between 0 and 19 minutes. All right. So let's see what questions they have. Yes, is there a question? All right. So this is what it says. Can we explain why S of t should be an increasing function? Well, S of t, according to this, is distance, right? And then Michael, I don't know if it's Michael from our class or another Michael, we'll see. So Michael is going up and down a hill. So therefore, if this is the starting point, and this is where he's gonna finish, right? Well, as he goes up and down, we are incrementing the distance he's at from the starting point, right? So at the end, so if he finished here, then we have been increasing the distance that he covers. So that's why this should be an increasing function, like it shows on the graph. It's going up, it's an increasing function, right? Then the second question says, can you find a function for Michael's speed? So notice that it doesn't say velocity, it says speed. For those of you that take physics, what's the difference between speed and velocity?
Speed is total distance over time, and velocity is like displacement, or the opposite.
So speed is a magnitude, and then velocity is the magnitude and a direction.
Right, that's the big difference. So velocity can be negative or positive. Speed always is gonna be positive because it's the magnitude, okay? But there is a relation between the speed and the velocity, which in this case, if this is the distance, right? This function is the distance. To find the velocity, then we will have to find the derivative, okay? So the velocity is just the derivative of the position. So the speed is going to be the absolute value of that velocity or the absolute value of the first derivative, okay?
Yeah.
That's all that is. So let's look at C. C says, Michael's acceleration is the rate of change, the rate at which his speed is changing with respect to time. How can we interpret the second derivative of S of t? Well, the second derivative of S is the first derivative of the velocity, right? So they're saying that this is the acceleration. So a way to interpret the acceleration is that the acceleration is the rate of change of the velocity. So remember what we have studied. The second derivative, which in this case is the acceleration, provides me information about the velocity. And the velocity provides me information about the function. Okay, so second derivative provides about information about the first derivative, and the first derivative provides information about the function. Okay. On part D says, can you find Michael's speed and acceleration at the time t equals 15? Yeah, all you gotta do is find the velocity, plug in 15, find the acceleration, and plug in 15 there. Okay, that's all you're gonna need to do that. And then here it says, at what point do you think the hill was the steepest? So let's talk about that for a second. So if we're talking about how steep something else is, then we're basically talking about the slope at that point. So the slope is the derivative. So this question is talking about when is the derivative maximus, or when the derivative is the highest. That's what you will need to do there. And then what you're going to do is find the derivative, set it to 0, find that value, and use that value to answer the second question. How far has Michael traveled to this point? So you just plug that point into the actual function, and that's it, okay? But this is going to be part of what I'm going to ask you to do. I'm going to go over an example to clarify any of the things that you might need to do here, okay? I just want to go over these definitions, make sure that we do understand what they mean, okay? So the first property, it says the following. If a particle P moves on a straight line and its position is given by the displacement function S of t, then we have these things. So let's talk about that. On the previous example, Michael is not moving on a straight line. He's going up and down a hill. So on that example, we can talk directly about distance, okay? But here, we're moving on a straight line. So if that means if this is the origin, could mean that we move to the right and then we can move to the left or vice versa, okay? When we do that, then we use displacement, all right? So this is saying what I just mentioned. The velocity is the derivative of the displacement or position function. The acceleration is the second derivative of that displacement function, or the first derivative of the velocity, okay? Now, initial condition. The initial condition is when the time is equal to 0. When the time is equal to 0, then we have S of 0, the initial position, the initial velocity, and the initial acceleration, okay? And this is the relation between all of them. If I have the displacement and I need the velocity, then I need to differentiate S with respect to t. If I need the acceleration, then I need to differentiate the velocity, which means is the second derivative of the position, okay? That's what is important to us. Notation-wise, this is how the notation is gonna work. M times S to the -1, actually that means the units of velocity. So in this case, that means meters per second. And these are the units for the acceleration, so meters per second squared, okay? Why? Because when we differentiate, we're differentiating with respect to time, t, and then we're calculating what? A rate of change, so a rate per unit. So that's why we have that notation. Now, this is what we actually need to know when we are making interpretations of displacement, okay? We need to know these three things. Let me see who else is trying to join the class. Anjane. Mr. Anjane, were you late? Like 10 minutes late, mister. You need to get on time in this class.
Yeah, I had the other link bookmarked from previously, so I had to change that.
Yeah, all right. So this is what we need to take into account, all right? Interpretations of the position, S of t, right? So the position, when the time is, if the position is 0, is because the particle is at the origin. If the position is positive, then because the particle is at the right of the origin. If the position is negative, then it's because the particle is to the left of the origin, okay? So basically, we have a line. This is the origin. Here, S of t will be positive. Here, S of t, the function, will be negative, right? So you're to the left, to the right. Signs of the velocity. If the velocity is equal to 0, that means that the particle is at rest. At that particular moment, it's not moving, okay? Or it's changing direction. That could be also that. If the velocity is positive, then the particle is moving to the right. So when the velocity is positive, the particle is moving in that direction. When the velocity is negative, then we're moving to the left. It doesn't mean that we are at the left of the origin, okay? So maybe let me erase that so you don't get confused. Velocity positive, you're moving to the right. The velocity is negative, we're moving to the left. We could be at the left of the origin and still keep moving to the left, right? Or we could be here and still move to the right. So that's why I changed this graph. Then the acceleration. If the acceleration is equal to 0, that means that the velocity may be at a maximum, at a minimum, or is possibly constant, okay? Velocity. If the acceleration is positive, the velocity is increasing, and if the acceleration is negative, the velocity is decreasing, okay? We're gonna make analysis of particle moving, that's why we need to know these things, okay? Let's see. Then we have this chart. This is useful information when you are reading a word problem. It says phrases used in questions. Initial condition, the time is 0. At the origin, the position is 0. When it's stationary, that means that the velocity is 0. It's not moving. When the particle is reversing, the velocity is also 0. When the velocity is 0 again, then there is a max and minimum or displacement. Notice that in velocity,
What do you mean by reversing?
going in the opposite direction.
Wouldn't the velocity not be 0 if it's going in the opposite direction?
Say that again.
Like, why is it 0 if it's going in the opposite direction? It's still moving.
Well, because at that moment it's going to change direction. Okay, so just think for a second that you're moving to the right, and then now you have to come back, right? If you have to come back, then you got to stop, turn, and move on the other direction. That's what that means when you're reversing, okay? So there is a sudden stop, and then you come back, or you go in the opposite direction. So what I was saying is that keep in mind that then when the velocity is 0, these 3 possibilities are present. So we will need other information to know or to decide what's happening, okay? When there is a constant velocity, the acceleration is gonna be 0. And if we have a maximum or minimum velocity, the acceleration also is 0, okay? So we need to keep all this in mind when we're making an analysis. And we will do that, or at least part of that today. Let's look at the speed. I mentioned this earlier. The speed is the magnitude of the velocity, so the speed is the absolute value of velocity. In terms of notation, notice that here, they're using uppercase S to refer to speed and lowercase s to refer to positions. So just make sure that you don't get confused by that. All right, so when is a particle speeding up and when is a particle speeding or slowing down? If you have velocity and acceleration and they have the same sign, meaning either both positive or negative, then the particle is speeding up, or the velocity of the particle is what? Increasing. If they have opposite signs, then the particle is slowing down. Okay? All right, so that's what we're going to do with this example. So I'm going to tell you the following. We might be able to do part of this and then I'm going to ask you to finish it up and also do the problem at the beginning, at the opening problem. And that's basically the work that I'm going to ask you to do from this section, at least today. All right. So let's take a look at this then. It says example 1. So let me write in here. Example 1. Let's talk about this, right? It says an object moves in a straight line with a position given by this. So this is the position function. T squared minus 4t plus 3 centimeters from the origin, which in this case is O. All right. And the time t is in seconds. So t is greater or equal than 0 and is seconds. So the first question there is find expressions for the object velocity and acceleration. So let's try to do that. The velocity is the first derivative of the position. So that's going to be equal to 2t minus 4, right? The acceleration is the second derivative of the position, or equivalently, the first derivative of the velocity. So take the derivative of that, 2t minus 4, the derivative will be just 2. They're asking to find an expression for that and draw sign charts for each. Well, this one is really easy because the acceleration, no matter what, always is what? Sorry, I don't know why I put plus. The acceleration is always positive. Why? Because this is constant, right? So that's the acceleration. The velocity, when will be the velocity 0? If t is equal to...
I have a question. If the velocity is always 2, then shouldn't the acceleration be 0?
No, you're mistaken. So the acceleration is always 2, not the velocity.
Oh, okay, got you.
Okay, the velocity is 2t minus 4. When will be the velocity 0? What makes this 0? What value?
2.
2, right? So the velocity is 0 at 2. And if you look at this, this is a line with a positive slope. So that line will cross like that, which implies that before 2, the velocity is negative, and after 2, the velocity is what? Positive, right? While the acceleration is always positive. So let's do an additional graph so we can actually see what's going on here. So this is basically what's happening. Actually, I'm going to do that graph here. So we have the velocity, which is this, and that's a line, y-intercept at -4. So let's say that line represents my velocity. Here is -4, right? So this is 2, because we just said that the velocity is 0 at 2, right? And the acceleration is a constant. So this is the acceleration, which is always 2, right? That's the situation we have there. Now, they don't ask about this. They ask only about this sign chart. But I think this will help us in the following problems. Is there any particular question for part 1? We're good? All right, looks like we are. So let's look at number 2. Number 2 says, find the initial conditions and explain what is happening to the object at that instant. So initial condition is when the time is equal to 0. So we need to determine what is s of 0, what is the velocity at 0, and what is the acceleration at 0. Okay? So let's plug in 0 into the original function. T squared minus 4t plus 3. So that will give me 3, which is a positive value. The velocity at 0,
-4.
-4, and the acceleration at 0 is constant, is 2, right? Okay, so let's make an interpretation of this. What does it mean that the position is at 0 is 3? Well, that means graphically, if this is the origin, it means that the particle P is 3 centimeters
Away
to
from
the
it.
right of the origin, right?
Yeah.
That's what it means so far.
Yeah.
What does it mean that the velocity is 0? I'm sorry, that the velocity at 0 is -4. Look at the chart. What does it mean when the velocity is negative?
It's slowing down.
It's going backwards.
Is moving to the left, right?
Oh.
So this means that P is moving to the left. So the particle is here, 3 centimeters from the origin, but it's moving in that direction. It's moving to the left, right? What does it mean when the acceleration is positive? Look at the chart.
It's moving.
If the acceleration is positive, what happens with the velocity?
It's slowing down.
It's increasing. Look at chart A5. It says acceleration greater than 0. The velocity is increasing.
Oh, okay.
So velocity is increasing. So let's put all that together. So what's happening in the initial condition? So let's write down a sentence. What could we say then, given these 3 pieces of information? Let's see. Let me pick somebody who can help me out. Any volunteers? Or should I pick a lady named Lucy? How's that? You're the lucky winner, Lucy. So how could we put all this together in one sentence? What's happening to the particle?
Combine them? I don't know.
You don't know. Okay, anybody can help me? Miss Zoe Gray, can you help me? Huh? No? Give it a shot. It doesn't matter. We don't have to be perfect. Let's give it a shot. What would you say if you have these 3 pieces of information? How is this particle moving? What's happening when the time is 0?
I'm not sure.
Not sure. Okay. Anybody wants to give it a shot?
I'll give it a try, but I'm not sure.
Go ahead.
So point P is moving 3 centimeters to the left towards the origin, and its velocity is increasing.
Say that again.
Point P is moving 3 centimeters to the left towards the origin, and its velocity is increasing.
Yeah, not that bad. Okay, so I will write something like this. At time equal to 0, right? The particle is 3 centimeters to the right of the origin, moving to the left at an increasing velocity, right? Let's look at this. Let's look at this maybe from this graph. That's when the particle, the time is 0. This is the velocity, right? And that's the acceleration. Well, if you look at the graph of the velocity, which is a line, the slope of that line is 2. That's why the acceleration is 2, right? So that let me know that this, at least graphically, does make sense, right? And the position is 3. I don't have the position here, but the position is 3, and it's moving to the left, to the left. So it's getting close to the origin, right? Because if it's at 3 centimeters moving to the left, then it's trying to get close to the origin. All right, that's kind of what is happening there. All right, any particular question? Hey, I don't see Julia. Jack, do you know what's going on with Julia? Oh, she's there. Okay. All right. Just I didn't see your face, so I didn't know you were logged in or not. All right, let's look at number 3. All right. So number 3 says, describe the motion of the object when the time is 2 seconds. All right, so well, let's do that. When the time is 2, then we're gonna do the same analysis, okay? We're gonna find S of 2. We're gonna find the velocity at 2, and we're gonna find the acceleration at 2, all right? So, S of 2, plugging 2 into S, that's gonna give us 2 squared minus 4 times 2 plus 3, which is gonna be 4 minus 8, negative 4 plus 1 plus 3, negative 1, okay? The velocity at 2 is gonna be 2 times 2, 2 times 2 minus 4, so the velocity is 0. And the acceleration at 2 is 2, because it's constant, right?
Yeah.
So let's try to make a graph of this before we actually describe it. So here we have the origin, right? The position is -1. That means that it's to the left of the origin, 1 unit, right? So the particle at time 2 is 1 centimeter away of the origin from where? From the left, correct? That's what that means. Now, let's try to put these two together. Velocity equal to 0. What happens when the velocity is 0? Look at the last, well, let's look at the charts. If the velocity is 0, the particle is what?
It's not moving, right?
It's not moving, it's at rest, right?
Yeah.
It's at rest. But the acceleration is positive, right? Because it's 2. So it says that it's at rest with a velocity, with a what? If the acceleration is positive, what does it say about the velocity?
It's going to increase.
It's going to increase. So let's think that for a second. If you look at the last chart, there the velocity is 0, right? What are the 3 possibilities? That is stationary, that is reversing, or that we are either at a max or a minimum displacement, right?
But when you say reversing, you mean like going from positive to negative or negative to
No,
positive?
reversing, I mean that
Opposite direction.
exactly. If this particle was moving to the left, now it's going to move to the
Yeah,
right.
so it goes from positive to negative or negative to positive.
Not necessarily. Because look, if you're in this position and you move to the right half of a centimeter, you still are in the negative side. So we were on a negative position, we still are in a negative position.
So it's reversing.
Right, just because we're reversing, that doesn't mean that we're changing signs. Make sense?
Yeah, it makes sense.
Okay, so it's just reversing. So there are 3 possibilities. It's either stationary, it either reverses, or it's a max or minimum, right? So how are we going to choose which one is actually happening out of those 3? Well,
Okay.
that's why I made this chart.
You can test them.
Look, this is the position at 2, right? Because this is time. So when the time is 2, the velocity, which is this line, is 0. The acceleration is constant, right? So look at the graph of the velocity. Before 2, how is the velocity? Negative. And after 2, how is the velocity?
Positive.
So what do we have? When the first derivative, which is the velocity, changes
Versus.
from negative to positive, what do we have?
Reverse.
Forget about this for a second. Just think in normal functions. If your derivative changes from negative to positive, what do we have in the function?
Increasing.
No,
Concave up.
no.
Negative.
Not sure.
Can you repeat the question?
Yeah, concave up.
Here the derivative is negative. here the derivative is positive, right?
So it's
So what do I have?
You have a minimum.
Concave up.
yeah.
I have a minimum.
Yep, minimum.
So
Yeah.
now let's put that together, right? Which in this case is gonna be that is concave up, right? Now, so the velocity is 0. Because of this graph, I can see that the velocity before that changes from negative to positive. So all this says is that the particle is at a minimum displacement, right? And is about to what? To increase the velocity, okay? So let's put all that together. So the particle, or at time equals 2, the particle is 1 centimeter to the left of the origin.
I can't see.
You can't see, put your glasses on, girl. Just messing with you, sorry.
No, I know.
All right, at time 2, the particle is 1 centimeter to the left of the origin. The particle is at its minimum displacement, right? About to increase the velocity. So in other words, the particle is here, right? It was going down, now it's going up, right? So in order to go up, it's gonna start what? Increasing the velocity. In this particular case, we can see that the velocity actually is aligned, so it's gonna have a constant velocity. All right, that's why the acceleration is 2.
Could you also say at that point the velocities or the object's also stationary?
Yeah, at that instant it's stationary because it's about to actually change direction, right? From going down to going up. Makes sense? So you can also say that. All right, so look. Actually, I went over your class 4 minutes, so I apologize. So this is what I want you to do. I want you to finish 4 through 7, work them out, so we can discuss them next class. And I want you to go back and work on the open problem, okay? Now that you have a little bit more of idea. So let me stop recording. And before you guys go, if you don't mind, wait. Need to stop recording. I don't want to end the meeting.